My name is Alfonso, but everybody call me Fons. Uh, I have been around the Elixir community for the last 6 years, and since 2021, I am always happy to work with nerves and looking to know more about nerves and create something. So, uh, in my current job, we are working with nerves in AWS IoT Core and AWS Greengrass. So we have learned a lot of stuff, and we have been working on this for the past year, more than a year, maybe a year and a half. Just giving a context about what we do or what I do in my current job, we have a point of purchase in different cities of the world where you can go with your smartphone, scan a QR code, open some shelf, fridge, or something to some place to buy something, to get something, and through video recording, artificial intelligence, computer vision, we are able to understand what you are taking and then just charge to your credit card. Uh, so, uh, okay. So when we were building up this product, at some point, I started to build our dashboards with live view. We were not running anything with Elixir, but at some point we wanted to get real-time data, and especially we wanted to understand what was happening with our devices in real time. So it was really nice to build our dashboards with live view. And as I was learning more about that, I understood that my case of having millions of sockets, web sockets, connections, and real-time data was exactly the purpose of the original OTP. So for that reason, I ended up learning about the NERVS project. And uh, we were like making some experiments in our embedded software with different languages, different embedded OS. And at the end, it was really easy to start a new project in the top of nerves. So I decided to just uh, build a new version of the system working with nerves and Phoenix, because we already had the first version of our backend in Phoenix. When we were like experimenting everything and understanding what was the right way to do it, uh, we I found the Nerves Hub, but I think it was in a really early stage of the Nerves Hub, and I was not really able to do all the stuff that I wanted to do. Now, Nerves Hub have all the features that I really need. I can say that today I could just switch my backend to Nerves Hub in terms of deployment and upgrades and monitoring, and it could work. I mean, it has everything. But as long as I keep working on my own system without Nerves Hub, and as Nerves Hub was like adding more features, I just use the code of Nerves Hub to understand how to do different stuff. We use Slipstream, and the reason is because Nerves Hub has everything solved as communication between devices and the backend. So what I need to say is that I have learned a lot of stuff from Nurse Hub. But as a company that needs to handle a lot of personal data and has a lot of concerns about privacy, safety, security, all this stuff, because we are making transactions with money in real time. We are identifying people because we need to know if it's an adult, so we can open the door of a fridge with beers or something like that. We need to identify the customer and then take decisions along the process. So for that reason, we needed to increase our security and to have some like legal compliance, be sure that we were not being in a risky path of doing technology. So for that reason, we were like looking for some services, technology, or whatever stuff that we could find in order to delegate that part of security. And we found IoT Core and IoT Greengrass. So this is the three most important layers of AWS in terms of IoT. So in the top, you have all this stuff about data, analytics, and probably something to consume and then process to make some inference about your data and all that stuff. In the middle, you have all the components about management and monitoring and controlling on all your devices. And in the bottom of that middle layer, you have IoT Core. And in the last layer, you have all about embedded systems, embedded applications. So if you see, you can run directly with a package, FreeRTOS OS, in your device. But we were already running with Nerves. We were so happy to work with Nerves. So for that reason, we find a way to just use some parts of this IoT environment. And we decided just to use some part of IoT Core, that it's mainly a backend to manage all your devices, and IoT Greengrass, that it's some sort of daemon running inside your device. So finally, we are just taking two parts of these layers of Amazon. So at the end, we decided to delegate all that security and safety part to Amazon. And so we were working with Phoenix and Nerves, and we said, like, okay, we need to connect that. We are just passing that ball to AWS, but how? And we were looking to find some guidance or some tutorial people packages, and we understood that nobody was like really doing that, at least like publicly. And I want to take the time to say thanks to the team, because these three guys have been like exactly in the hard work of figuring out how to connect every part of the system. So Fabricio is just working with all the backend. He was actually working on the WebSockets and all the distribution of the system. So it was not really something different that he wanted to do to connect the AWS. Jose Vicente, it's the person who is really understanding everything inside Nerves and how to build custom systems, how to add security and all that stuff. And by the infrastructure side, Matthias have been like working directly with the people of Amazon to understand and to get new features for our team to connect all this system. So Greengrass, as I said, we are using just two parts of the environment. So our requirements for like this release and what we were looking for was to be sure that the device that is trying to connect to our system, it's actually our device or like validated device. So we needed to identify our device and validate that the connection was not with some attack like man in the middle of something. Be sure that when we update our devices, we are not getting a malicious package from somebody else that it's trying to fake our packages. And of course, do it like remotely, like just send all the upgrades to a bunch of devices. And in general terms, like keeping it safe. So a really small glossary to understand the Greengrass terminology. I think it's something like a device. So you have device groups, so that's a thing group. And then you have artifacts, that it's a bundle. It's not exactly just an application. It could be like a serious, like a huge bundle of different applications, configs, binaries, statics, a lot of stuff. You just package everything over there. A core device in terms of Greengrass, it's like a sort of pointer to a specific ID of a thing. And then you have deployments, like it's not only the action to deploy a new firmware to your device, it's actually a group of steps that should need to be executed to deploy a new firmware to your devices. So this is a really high-level view of what we do right now. We have devices that we call it APOP. It has some keys inside, encrypted keys that are being sent to the IoT core. So as I said, it's sort of backend for your devices. And then when it's validated, the IoT core will generate a pair of keys. And then we take the key and send it to our device. So in that way, we establish a WebSocket connection, encrypting the data and using the keys to communicate between our system and the embedded application. So how to do it? When you're working with this inside Amazon, you have the option to use the console or to use the API. So the first steps, you need to validate your idea. So if you go to the console, then you have the IoT side, then you have a submenu with Greengrass, and then you have your core devices. So there you can just register a new device, you need to generate a key, a pair of keys, and then set the keys in your device. So when you need to make an upgrade in your device, you need to generate a component. A component, it's like it's a package with the scripts and the firmware that you need to run, and the dependencies that you could need in the process of upgrade your device. So when you have your component, you have the list of your devices that you have registered in the IoT core, and then you can send a deploy and see in real time what is the status of your upgrade. So as you see, you can see like some devices are in the queue of being upgraded, and some devices are already upgraded, and some devices could be in error status. So how to do that? Like, we are building our firmware in the cloud. So for that reason, we are using Docker, and we are using GitHub Actions. So we push all the code to our repo, and then we have a long process to validate all and build the firmware inside the cloud. When we have the firmware, we have the first package. So then, as I said, we have the components, that it's like the bundle that you will send as an upgrade to all your devices or a group of devices. So you require a receipt, that it's a YAML. Of course, you have inside the Amazon console some default receipts, and actually you have like firmwares, like public version of firmwares that can do some stuff. But this is like our version of the receipt. I think the interesting thing here is that if you see like in the middle of the code, you see lifecycle install, and if you go to the last skip if, you can establish like a way to skip your upgrades. And in the part of the script, it's a small version of what we do. But basically, we have the Greengrass daemon running and waiting for a new deployment. And when we receive the signal that there is a new version of the firmware ready to use, we use the daemon to download the package, like install it in the second partition, and then do some stuff before restart our device, and then just start with the new version of the device. Okay, so it's I think the most interesting thing in the part of the receipt. So when you have your devices registered inside the IoT core, you have a bundle that you can send as an upgrade. The next question is, okay, but how can I do it inside Nerves? Because this is not a Greengrass OS or some version of the operative system of Amazon. So you need to build a custom system. So just following the guides of Buildroot and a lot of work understanding the requirements, I think there are two packages for Greengrass. But we decided to just take the Java version and understand how to add the package to run it inside Nerves. So I have to say that it's actually just to enable the XOR package inside build root, and then add the open JDK package, and that's all that you need to run the jar from Greengrass. Just an example, you can find packages with the search inside the tool. And when you already have your jar inside your nerve system, your custom nerve system, you just need to add some custom runtime where you can define how do you want to start your system. So we just add our runtime, and just to have an idea what do we do is really simple. We just added like an update configuration where we understand the signal that it's being received from Greengrass or IoT Core. And we just check the versions of the binaries, and we just start the process of the installation, or just keep going and probably log some errors. What I need to say is that here we already know that we are getting a straight connection to the AWS core, and we are like safe, and we are not getting packages from another source that it's not the AWS IoT core. So probably if you have worked with nerves, you have saw this diagram about the partitions, where you have the U-boot to start and a boot for a couple of partitions, so you can switch between A and B when you are like upgrading your device. So you are running with the partition A, you upgrade the partition B, and then you reboot and try to start with the partition B. And if there's an error, you can go back to the partition A and notify that something is wrong with the partition. So you don't need to do it, but in our case, we added a partition called Greengrass, and we needed to add a user, or we decided to add a user for this partition in order to just give the permissions to get data from that partition. So in that partition is running the Greengrass jar, and this is like the simple way to tell the firmware up where it's the jar hosted and where could be like started from the binary. So this is a simple view of how we are just adding the partitions to our system. We are just adding the Greengrass Connect user. That's the way we called it. And when you start through your runtime, you just say that you want to start or mount the other partition that you are adding. So as you are running your Greengrass daemon inside your nerves, and you are having all your devices registered inside IoT Core, then you can create a deployment and send it as an upgrade. So this is where all these pieces ended as a succeeded state in an upgrade of your dashboard. We are not doing this manually. Of course, we have a backend that it's connected to the API and it's doing these processes in a simple way that we just register our device in our own dashboard, and then behind the scenes, all the API manage everything. But for our requirements, we are using GitHub Actions to control the versions of our firmware. So what we do behind the scenes is to commit the code, make it pass all the tests, build it in the cloud, and then that will send the deploy to our devices. But it's actually is controlling the API of AWS IoT Core. And what you saw in the screenshots about the console, it's like a step by step. If you want to do it like manually, or if you are just starting to validate your idea.
Awesome. Thank you very much, Fonz. I've enabled it so everybody can unmute themselves to ask questions now. I'll steal the first question, and that would be this was really cool. In a presentation about security, I think there was one thing missing that I didn't hear, so I'm wondering what your thoughts were on it, and that's working with the ATEC crypto chip, or the NERVS key, in other words, for device identity and security, especially when connecting up to AWS IoT Core, because it does integrate with that. So is that something you looked at, and what were your thoughts around that?
Yes. That was something that I saw when I was testing NerbScope, and the reason I just decided to put it in a secondary place was because my operations team asked me to be sure that they could ask for like a huge amount of chips to be deployed like in the next months. And at that time was not possible to have like this like 10,000 chips or something to deploy that. So that's the reason I just put that away. And that's the reason we are trying to increase the security between communications, because it's something that you can solve it with hardware, but in terms of operations, you need to have the hardware ready to deploy. And that's a huge concern.
Yeah, so you got hit with the chip shortage. Sounds like probably a couple of years ago as that went really bad. Yeah, they were out of those chips pretty badly. Cool, yeah. Thank you, Fonz.
I could have a question for all of you guys. So what do you think about sending? Well, you have the option to copy the daemon or the binary to your device and copy your keys as well when you're building your firmware. What we do is to build the firmware without keys, and then between these communications with the IoT core, we send the keys in order to upgrade, in order to connect to the side of the IoT core where the device receives the new firmwares to be installed. I don't know if somebody has an opinion about not getting the keys when you are building the firmware and getting the keys through communications.
Yeah, I don't know how everybody else has done this, but we've used the ATEC chip to great success. But moving towards other devices, especially with the chip shortage, which we got hit with as well, I'm not sure there is a solid solution to this problem. I mean, especially with like the IoT kind of infrastructure where, you don't necessarily have a TPM module that you can just leverage to store secrets, we don't have that yet.
Yeah, there's been talks of trying to support Trust and Go since that's, Trust Zone, since that's getting popular on some of the chips coming out now, but yeah, things aren't quite there yet in the Nerves ecosystem. Clay, did you end up doing your own key generation then for your use case?
So the devices we've got in production now have the ATIC chip.
Okay.
And so we're totally just relying on reserve supply to limp those along as best we can. For the next generation, we're as stuck as everybody else with, how do we authenticate? Where do we store these things that's not just in the clear on a device?
Yeah, the good news now is at least the supply has come back. So the 608Bs are on the shelf in large quantities, and they seem to be backwards compatible, obviously with the 608A, but also I believe with the 508As and Bs, and I forget if it's the 100 series, something else in there too. So anyway, the hardware approach seems like it's probably stable now, unless you're seeing something that I might have missed in that.
At least from my perspective, for new device, I've got 3 generations of devices that we have to deal with. One of them is in production, and we've got a reserve supply of the chips. Another is on the way. We haven't figured out how to solve this problem yet. Although hearing that there's availability for devices that's news to me. I haven't been looking lately, but that's awesome. We also have in-field devices from a previous generation that we're planning on doing field upgrades to that do not have the hardware. They also tend to be physically inaccessible in places that you just can't send a person to have them, install hardware. It's tricky.
Yeah, that one's painful.
Yeah.
I'll chip in and just say, as someone that's kind of new to the ecosystem, this is really blowing my mind, the class of problems that you have working with embedded stuff. I never would have considered this, which I know is not much of a contribution, but I thank you all. I feel like I'm just learning so much by just exposure.
Yeah, absolutely. Okay, Fonz, I'll throw my thoughts out there too. I've had to do this with both the hardware route and in generating certificates as files before. Obviously, if the hardware is available, I prefer the hardware, but there was the whole chip shortage that kind of ruined things. In that case, and actually, so last month I mentioned one of the things that we're doing over with GridPoint as well, where we had to convert devices that are in the field that don't have the crypto chip, and they're not going to be able to have it because we can't pull those devices out of the field. And one of the strategies around that is we're having the device roll its own private key. The server has a signing certificate, so we have an endpoint that device can go through, secure endpoint that we can talk back up to, and it can get its public key signed by the server. It never gets, the private key never gets transmitted over the wire. And then it's got a signed key that it can go use to, this is actually one project where we're not using IoT Core, but I've used it for a ton of other commercial projects. And it works basically the same way in this case, but once you've got that signed public key, then the other end will let you connect up and it actually came from your services. So that's one of the ways that we've approached that. And it sounds like maybe it's along the lines of what you're doing, but what I was kind of unclear about is, are you sending the private key down in that bundle, or are you generating No, okay.
It's
cool.
exactly a certificate, yeah. And
okay.
you have the lifetime, little short lifetime, where the daemon is you're getting another certificate, and then check again if there's a new firmware.
Cool. Yeah, it sounds like you're doing it the best way, at least that I can think of, without having hardware available.
Good to hear that. Thanks.
Is anyone else either using IoT Core or looking at using IoT Core or Greengrass now?
I've got some downward pressure from corporate for at least doing an investigation into it. I think the main interest there is sort of running compute pipelines on like events streaming up to AWS, and how we could leverage Greengrass to enable that. But our current generation of stuff is all using a kind of a homegrown synchronization system and Nerves Hub to do device updates.
Gotcha. Synchronization for the firmware update side of things, or something else there?
No, data, streaming events.
Oh, okay. Okay, cool. So, so basically, if I were to just oversimplify that, pushing more of that logic down to the edge from the cloud, is that kind of the gist of it?
Yes.
Cool. Yep. Common scenario these days.
Yeah.
Well, you've got a good system for it, at least.
Yeah, I mean, Nerves and OTP have been absolutely fantastic for this kind of work.
Mm-hmm.
And we were kind of talking about this, I guess, right at the beginning before we got into the main part of the presentation. That one of the things that gets overlooked really easily, I think the original example was Go, and being a long time C programmer myself, the recognition that most software spends most of its time being maintained and not being written. Any language that you can write in that makes it easy to maintain is better.
Absolutely.
So yeah, that was a big level up for us with Elixir and Erlang ecosystems. I can reason about what my code is doing so much better than I can with non-functional imperative kinds of languages.
Yeah, that's been one of the great use cases for it. It's just been absolutely amazing building products in Elixir on top of Nerves now compared to some of the other options out there. All right, sounds like folks are out of questions. Fons, thank you very much for the presentation. It's been great. Absolutely wonderful to hear about Greengrass and how you've been able to integrate that into Nerves.